Before we delve into the profound implications of the Large Hadron Collider, LHC, we must first understand what this extraordinary machine truly is and why it holds such an esteemed position in the world of physics. Imagine a machine so powerful that it can recreate the conditions of the universe just fractions of a second after the Big Bang, a device that offers humanity the unprecedented ability to peer into the fabric of existence itself. This is not science fiction. This is the Large Hadron Collider. Operated by CERN, the European Organization for Nuclear Research, the LHC is a 17-mile-long ring of superconducting magnets buried deep beneath the border of France and Switzerland. It's the largest and most powerful particle accelerator ever built, representing the culmination of decades of research, innovation, and international collaboration. It's a scientific marvel, a technological cathedral designed to answer the most fundamental questions of our universe. Founded in 1954, CERN has grown into one of the world's foremost centers for scientific research, uniting 23 member states and thousands of scientists under a common goal, to unlock the secrets of matter, energy, space, and time. And while CERN operates a vast network of machines and detectors, the LHC stands as its crown jewel. Picture it as an invisible racetrack, but instead of racing cars or horses, it hurls subatomic particles, protons, at velocities approaching the speed of light. Inside this underground ring, two proton beams travel in opposite directions, guided by immense magnetic forces and chilled to a temperature colder than the emptiness of space itself. When these particles finally collide, they unleash energies so great that, for a fleeting moment, they recreate conditions akin to those that existed microseconds after the Big Bang. The resulting explosions are monitored by four colossal detectors, ATLAS, CMS, ALICE, and LHCb, each acting as a high-tech observatory, capturing the birth of particles that may have existed only in theory until now. These collisions allow scientists to study the tiniest building blocks of reality, quarks, bosons, leptons, and to search for phenomena that transcend our current understanding of physics. The LHC played a pivotal role in confirming the existence of the Higgs boson, a mysterious particle that endows matter with mass. This discovery alone earned a Nobel Prize and fundamentally reshaped our understanding of the universe. But the Higgs is only the beginning. What makes the LHC so captivating isn't just what it's capable of doing, but what it might do. With every collision, we inch closer to answering age-old questions: what is dark matter? Do extra dimensions exist? Are there forces or particles we've yet to imagine? And perhaps more importantly, what are the potential consequences of probing so deeply into the very structure of the cosmos? Within the sanctified corridors of CERN, where reality is questioned and rewritten daily, a revelation has stirred awe and trepidation alike. Brian Cox, a former CERN physicist and a respected voice in the scientific community, has openly described the purpose of the LHC as a way to recreate a small version of the Big Bang. It sounds surreal, fantastical even, but it is a very real goal. The LHC seeks not just to simulate cosmic origins but to grasp them, to wield the very energy of creation itself. Picture it, temperatures hundreds of thousands of times hotter than the Sun, conditions so extreme they could only exist in the newborn universe. These aren't metaphors, this is literal, controlled cosmic fire. And in conjuring this primordial chaos, the LHC doesn't merely recreate the past, it opens portals into possibilities we have yet to fathom. But immense power carries immense risk. Let's rewind to a chilling event from the past. In 1978, Russian physicist Anatoly Bugorsky was working on the U-70 synchrotron in Protvino, when a freak accident exposed his head to a high-powered proton beam. The beam entered through the back of his skull and exited near his nose, burning a line of destruction through his brain tissue. Bugorsky described seeing a flash brighter than 1,000 suns, yet he felt no pain. Miraculously, he survived, though he suffered partial paralysis and permanent hearing loss. His experience is a grim reminder of the raw, almost alien energy involved in particle acceleration, energy that defies the norms of biology and physics alike. With the LHC, the stakes are even higher. Some theorists have proposed scenarios that sound like science fiction: the formation of miniature black holes, tiny rips in the fabric of spacetime that could, under the wrong conditions, grow out of control. Black holes are cosmic predators, devourers of stars, planets, and potentially entire worlds. While CERN insists that any such black holes would evaporate almost instantly via Hawking radiation, the mere suggestion is enough to stir anxiety and fascination in equal measure. To understand how the LHC might create such an entity, we need to appreciate the incredible density of energy created during a collision. Theoretically, if energy is compressed into a small enough region of space, a black hole, however tiny, could be born. Scientists argue that such black holes, if they appear, would be harmless and fleeting. But we've never witnessed this before. How confident can we be about the behavior of something we've never seen? For many, the LHC is a beacon of human progress, a shining example of what we can achieve when we come together in pursuit of knowledge. For others, it's a Pandora's box, brimming with both promise and peril. As we push against the boundaries of known physics, we also cross into territories where safety nets become thinner, and where consequences may lie beyond our current comprehension. So, should we be worried? Should humanity fear the creation of artificial black holes, the tampering with dark matter, or the potential discovery of alternate dimensions? It's easy to be swept up by dystopian fears. But the truth is more nuanced. The scientists at CERN are deeply aware of the risks and conduct exhaustive safety assessments. Every experiment is reviewed, tested, and simulated with meticulous care. There is no recklessness, only a cautious march toward understanding the unknown. And yet, the unknown remains. The LHC is more than just an experiment. It's a philosophical statement. It dares to ask, what lies beyond the veil of what we know? It invites us to consider not just the universe's mechanics, but its origin, its purpose, and our place within it. With each proton collision, we dive deeper into the mystery of existence itself. The discoveries made here could one day explain dark matter, solve the puzzle of gravity, or open windows into entirely new dimensions. But they could also unsettle our current theories, forcing us to rewrite the textbooks of science, and perhaps even reshape our understanding of reality. In this great quest for knowledge, humanity stands at a precipice. The LHC is not merely a machine, it is a symbol of our collective curiosity and courage. It reflects the age-old desire to understand the stars, not by looking up, but by breaking down the building blocks of matter itself. As we continue this journey, we must carry not only the tools of science, but also the wisdom of restraint. We must ask not only what we can do, but what we should do. In the end, the Large Hadron Collider is a testament to both the brilliance and the boldness of the human spirit. With every new experiment, we step closer to answers that have eluded us for millennia. We peer into the heart of the universe and ask, what are we made of? Where did we come from? And what else might be out there, waiting to be discovered? The answers may change everything.